Okay, recording. Yeah. Dear students, let us move on to next problem. Question number 37. If this matrix is a symmetric matrix, then we have to find the value of x. See, for symmetric matrix, we know that with respect to diagonal elements, the corresponding element should be same. So 2x plus 3 should be equal to x minus 1. It's a linear equation in terms of x. Solve for x, transpose this x this side and 3 the other side. We get 2x minus x is equal to minus 3 minus 1. 2x minus x will be x, minus 3 minus 1 will be minus 4. So minus 4, option C. And we can cross check, put x equal to minus 4. 2 into minus 4 will be minus 8. Minus 8 plus 3 will be minus 5. Put here also x is equal to minus 4. Minus 4 minus 1 will be minus 5. Yes, both the elements are same. Okay, let us move on to next problem. Question says if A and B are matrices of the same order, then AB transpose minus BA transpose is a skew symmetric matrix, null matrix, symmetric matrix, and unit matrix. Among this, which one true? See, before I go ahead, no, purposefully I have taken some of the problem from NCERT, which is of MCQ based, because those questions are also important. Correct, na? Okay, fine. So let us move on to this. So A and B are matrices of same order. Only then this is defined, as you are aware. And now coming to this, let us take the given matrix to be C. See, from the option, one thing is very clear. They are talking about skew symmetric and symmetric. Surely it need not be always null and unit. Okay, need not be. Okay, it may or may not happen. But this among A and C we have to check. See whether it is symmetric or skew symmetric. Transpose is mandatory. And from here one thing is very clear. Sir, I have got one shortcut like this, so I can forget the concept of symmetric. No, you can see some problem like this. Okay, that's what I'm saying. Each and every method is important for us. We can't be choosy. I want only this method, not this. No, we should learn all the method for the success. Now taking transpose on both the sides. Okay, I have taken, okay, taking transpose both the sides. Now, we know that, now comes properties. We know that, see, we have minus and we have, see, product of this two is one matrix, product of this two is one matrix. We know what is A minus B whole transpose. It is A transpose minus B transpose. So the transpose can be taken individually. For the first, this entire matrix is one matrix minus B A transpose the whole transpose. Now we have a product of two matrices. We also know that reversal law, that A into B the whole transpose is B transpose into A transpose. The order will change. So see, A and B change to BA. So here A, then B transpose. So this is the first matrix, the second matrix. So first will be, second matrix will come first. So B transpose the whole transpose, then A transpose. Okay. Then minus, again here this is first matrix, second matrix. So the second matrix will come first, that is A transpose the whole transpose. Understand here, A and B were without transpose, so they got transpose each. So now when I'm applying, B I already had transpose, and again one more transpose. Similarly, A transpose, again one more transpose because of the formula. Then B transpose. Now, what is, let's write it here. What is A transpose the whole transpose? It is A. Double time, if I take transpose, I'll get back the same matrix here. So B transpose the whole transpose will be B. Then here we have A transpose minus A transpose the whole transpose, nothing but this will be giving us A. Then B transpose. Now observe this and what we have taken as C. Compare both. If you see, plus sign is there for AB transpose, but here we have for minus. AB transpose we have minus sign. And for BA transpose we have negative sign, but here we have positive sign. So if I take minus out, minus into minus is plus, AB transpose minus to plus is minus BA transpose. One question will come, why have I taken minus common? So that I can get this. Now you see this and this bracket term both are exactly matching. So I will get minus then C, and the left hand side is C transpose. This is obeying which definition? Skew symmetric matrix definition. Therefore C is equal to AB transpose minus BA transpose is skew symmetric matrix. Okay, so option A is correct. Now for you, one assignment of this will be, let us suppose the question is this: AB transpose plus BA transpose, what type of matrix it will be? Everything remains the same. A and B are matrices of the same order. Okay, then try to perform that. Now let us move on to 39. Okay, if A is a square matrix, it's okay. A is a square matrix. A transpose it's A dash is its transpose. Then minus 1 by 3 A is concept based question. Already we know one result. What if wait okay, A is a square matrix, then its transpose. Be careful, A transpose given, but they have nowhere given A transpose. Let us cross check the question. Okay, question is right. So minus 1 by 3 into A. See, when you have got any matrix A, if you multiply by any scalar, if A is just a square matrix, you'll get back a square matrix only. Whenever you multiply a scalar, the order will not change. Since this is square matrix m by n, after multiplication of what we will get? M by m. Again we will get m by m square matrix itself. Need not be symmetric, skew symmetric, need not be unit matrix. So it is only an elementary matrix. Okay. Now let us take as a note. Can you comment in place of saying square matrix, if A is a symmetric matrix, then what is Ka? Okay, that's your question. And if A is skew symmetric matrix, then what is K into A? Which type of matrix it is? Okay, this answer is already there in PUC. Okay, the theorem number 1 and 2. After sum of symmetric and skew symmetric, there it is. Okay, and we have discussed the problem type. Let us see how many can comment this. Okay, I'd like you to comment. Okay, all the very best. Make a note of this. Okay, dear students, let us move on to question number 40. Let A yes, let A and B both be 3 by 3 matrices. See, problem of this type, no, it need not be 3 by 3. Even for n by n also same rule. Okay, nothing is going to change. Whenever we go for general way, no, order 2 by 2, they given 3 by 3, doesn't matter. N by n we can think of. Okay, then A into B whole transpose is equal to B into A. So this they are asking us, this will be true when? This is true if there are options: A skew symmetric, B symmetric, B skew symmetric, A symmetric for option B. Then both are skew symmetric. None of this. Coming to the solution. See, let us try to take what they have given. Now, that's what I said. No, all properties are important. A into B whole transpose is B transpose into A transpose. Now, I want it to be equal. See, let it be even square matrix. As soon as I take the transpose, order will remain same, but matrices will not be the same. Now they are asking, if at all this should be same, then what type of matrix A and B should be? Now see carefully. Here, if I have got two cases from here. Case number 1. If B transpose is equal to B, and A transpose is equal to A, then our equation number 1 will become B into A is equal to B into A, nothing but equal matrices. Here I have taken both A and B to be what? Symmetric matrix. Okay, symmetric matrix. Let us assume that this step only, okay, this step only. If case number 2, if both A and B are skew symmetric, if I say skew symmetric, what's going to happen? A transpose is equal to minus A and B transpose is equal to minus B. So equation number 1, if I substitute, since B transpose is minus B and A transpose minus A is equal to B into A, minus to minus plus, BA is equal to BA. Understand the logic. For symmetric, transpose will give plus sign. For skew symmetric will give minus sign. Since we have got product of two matrices and in the right hand side we have positive here, mean to say that either it should be minus into minus plus, plus into plus is plus. It can't happen that minus into plus or plus into minus. I'm talking with very elementary. This will give you minus. Nothing but here minus stand for skew symmetric, plus stand for symmetric. So since I have got product of two matrices here, if at all I want it to be symmetric, nothing but it should be equal to this. Since I have got plus sign here, surely these two should be both symmetric or both skew symmetric. Only then this can happen. But one is what? Symmetric, other is skew symmetric, this case. So skew symmetric, 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 skew symmetric will give you what? Skew symmetric. I mean to say minus will be out. Minus will be out. Skew symmetric, when I take this, minus will be out and here I'll get negative sign, but here I'll get positive sign. This is what I mean to say. Therefore, if at all I want positive sign, both should be symmetric or both should be skew symmetric. So here they have given only skew symmetric. Here they are given the other ways. One is skew symmetric, other symmetric, nothing but this case. And I'll get minus out. But I want plus. I hope this point is clear. Okay. First make a note, then we will take assertion reason type question. Okay, let us move on. This is the entire question. Okay. This is actually assertion reason type question. Usually this type of question will be in JEE mains. But even in PUC and CET level, this type of question is framed. I am not saying that question level they are asking of that. I am saying that type of question. So, as I said, I want to go for all the kinds. 55 plus is our target for 60 marks. So now, let us understand. Whenever you see statement 1, statement 2, and no, you just see the way the question is framed. A and B are the two symmetric matrices of the order 3. So coming to solution, symmetric they say. So A transpose is equal to A and B transpose is equal to B. Statement 1 is given. A into B, A and AB into A are symmetric matrices. Statement 2, AB symmetric matrix if matrix multiplication A with B is commutative. Now they are asking option A, statement 1 is true, statement 2 is false. Option B, statement 1 is false, statement 2 is true. Option C, statement 1 and statement 2 are true, and statement 2 is a correct explanation for statement 1. Nothing but to solve this, we are going to take the help of statement 2. If I am taking the help of statement 2 to get the answer for statement 1, then I am going to say option C is correct. If I am taking the help of statement 2. Here, coming to option D, statement 1 and statement 2 are true. Statement 2 is not a correct explanation for statement 1. See, in this assertion reason type question, this we call assertion and reason type question. Okay. Now, if any one of the statement is false, no problem for the student. Problem for the student is if both are true, then if we have got this type of a thing, but whether statement 2 is a correct explanation for statement 1 or not. Simple logic I am saying. If while proving or if I am proving statement 1 is true with the help of statement 2, only then Statement 2 is a correct explanation for statement 1 will be taken into consideration. If I'm not taking the help of statement number 2 to prove statement number 1, then it will be this, provided both are true. If any one is false, then option C and D out, only this we have to focus. Now come to statement 1. Now see, coming to statement number 1, they are saying A into B into A. See, now you cannot take an example and waste that time. That's what I'm saying. All the things are required. Concept. Now I will assume this one to be matrix C. I want to check whether it's symmetric or not. For symmetric or skew symmetric, transpose is mandatory. So I am taking transpose throughout. To avoid confusion, I have taken a rectangle bracket. Now recall the reversal law. What it says, A into B into C, the whole transpose is C transpose B transpose A transpose. Nothing but it will go from right to left. Now you see carefully. So if I just go for the numbering, this is first matrix, second matrix, third. So it becomes third, then second, then first. Similarly here, 1, 2, 3. So this matrix comes first. And one more thing, associative law, we know it is always true. So now you see, this matrix comes this matrix comes first, then second matrix, and then A, then transpose for all. Now see carefully, pay attention, listen carefully. Can we go ahead? See, around say you see, A transpose is equal to A, B transpose is equal to B, A. Okay, and this is same as the given matrix. So matrix C. If at all we are still more particular, see carefully, we just broke the inner bracket. No sir, I want to go with the bracket. Then we can take this one to be entire second matrix because the product of two, so one single matrix. So what will happen is BA the whole transpose, nothing but the second matrix here, then A transpose. Now again for this applying the reversal rule, A transpose will be the first, followed by B transpose, then A transpose. That's what I wrote directly. Okay, fine. So this is same as the given question. So therefore C is equal to A times of BA is symmetric. Similarly, we can take the second statement and check. It will be again what? Symmetric only. Taking transpose throughout, same procedure it is. So no need to explain again. So I'll get this one to be fast. Then this also I can split. Okay, and since A and B are symmetric, A transpose is A, B transpose is B, and again A. This is same as this, nothing but D. Therefore, it is also symmetric. So statement 1 is what? True. Coming to statement number 2. What is asked? Statement number 2. A into B is symmetric matrix if matrix multiplication of A with B is commutative. Means they are saying if A and B are commutative, nothing but A, B is equal to BA, only then A into B is symmetric. A into B is symmetric. Okay, let's check that is true or not. So since C and D is already used, I'll take E, then I'll take AB here. I have to check whether AB is symmetric or not. AB is symmetric or not, provided it is what? Commutative. Fine. If I take transpose, A into B the whole transpose, we are going to have change the reversal rule, B transpose, A transpose. But since A and B are what? Symmetric matrix, I can rewrite this one to be B and what? A. BA is, okay. Now see carefully. AB is not equal to BA, but since in the question they have asked us to assume that it is commutative in nature, from equation number 1, I can write BA same as AB, which is, okay, here. So correct now. Now I have got this, and now see carefully. Be careful, this is E transpose, transpose there. AB, yeah, AB is E. Therefore what? It is what? Symmetric. Therefore symmetric. But to go for the symmetric, one important condition they gave, it is commutative. Only then it is what? Symmetric. So this statement is also true. Now see carefully. When I have proved this to be true, I have nowhere used anything like commutative law here. It is only associative law. So even though statement 1 and statement 2 are true, but statement 2 is not a correct explanation for statement 1, because I have nowhere used the fact that it is commutative. Nowhere I have used. Therefore, option, which was not a correct explanation. Yeah, not a correct explanation. Option D is correct. And one more thing. This, no, it's both the way. Here, similarly, what I mean to say, we assume it to be symmetric, I mean to say commutative, then we got symmetric. Other way also true. What? If it is symmetric, then it is commutative also. If it is symmetric, A into B symmetric, then it is what? Commutative. Both the way it is true. Okay? Make a note. Okay, dear students, let us move on to next problem. Question says, if addition of two matrices x plus y is equal to this matrix and difference is this, find the value of x. See, at the beginning we had some numbers, nothing but alphabet inside the matrix in small letter. So usually matrices are denoted by capital letter and elements are in small letter. So as soon as I saw capital letter and it's equated to matrix, it's very clear that both x and y are matrices. Now we have to find the value of x. I will, after finding, no, I'll try to find y also. Who knows, if they ask y, how to do, etc. And if the multiples are different, that also I'll take as an example. So let us go ahead. Both are blue. It's black. For a while. Oh, black is in pocket only. Fine. Let us simplify solution. So see, since I want x, elimination method, y minus y will get cancelled. X plus x will be 2x is equal to, add this two matrices, corresponding elements. 7 plus 3 is 10. 0 plus 0 is 0. Then 2 plus 0 is 2. 5 plus 3 is 8. Since I want x divided by 2 on both the sides, x is equal to 10 by 2 will be 5, then 0, 2 by 2 is 1, 8 by 2 is 4. That is in option C. Even we could have taken one particular element different and then get the answer, but as I said, I want to completely solve it so that we can understand. Now let us suppose that, how to solve it, that's my motive for this problem was, let us suppose in place of x, they ask y. So there is no need to first solve x. What we could have done, suppose the question was to find y value, then question I am recopying again here, 7, 0, 2, 5. Then here x minus y is equal to the matrix 3, 0, 0, 3. Now just we have to change the sign. So when I change the sign, y, we have to change the sign. Understand, since I want to find y, I should not eliminate y, I should eliminate x. So change the sign. So plus to minus and minus to plus. And there is no sign, it means minus. Same school days. Okay. So now what will happen? X minus x will get cancelled. Write the cancel symbol properly. Cancel. And then y plus y will be 2y is equal to, now subtract the matrix. Now while subtracting the matrix, before we go ahead, just see here. Minus and multiply in, minus plus is minus 3, then minus 0 plus 0 doesn't make any difference, then again 0 here, minus to plus is minus 3, nothing but now we have to add these two matrices. Okay, I usually prefer student multiply negative in, then simplify, so that the sign they will not forget. Many directly they will write 7 plus 3 as 10, which is actually not true. You have to subtract. Now they will not make any, means you will not make any mistake. 7 minus 3 will be 4. 0 minus 0 is 0, 2 minus 0 is 2, 5 minus 3 is 2. Now from here, when I divide by 2 on both the side, y is equal to 2, 0, 1, 1. So the extra part I wanted to do. Now, first make a note of this. I want to erase this. Let us suppose the multiples are different, how to solve. I'm not giving the option. Just I thought, no, I will take that problem also. First make a note of this. Okay, fine. I hope you have made a note of this. Now let I change the question. Options I am raising. without any options, I'm going to give the problem now. Let us suppose that the question is something like this: x plus 2y is equal to this, and here 3x minus y is equal to this. Then you have to find x value also and y value also. Okay, just one question number 43 we can say, and then this will become 44. Okay, now see carefully. So how are we going to go about? Last time the multiple of x and y was same, due to which just by changing the sign or without changing the sign we are able to get x and y value. But here it's not the same. Again, using elimination method, either x or y. Now since I have asked both, let's suppose I want x. So to find x, I have to make x multiple same. Here x multiple is 1. Okay, so I'll multiply by 1. Okay, here x multiple is 3. I'll multiply by 3, so that the multiples of x become same. Okay, here I'm eliminating x, I mean to say I'm eliminating x, okay, to get y. So 3 into x is 3x, then plus 3 2s are 6, then 3 7s are 21, then 0 3 2s are 6, 3 5s are 15, then 1 into anything is same. Anything means any number. Okay, now around se change the sign. Plus will become minus, minus will become plus, and plus will become minus. So here very clearly we can see that 3x minus 3x will get cancelled. 6y plus y will be 7y is equal to 21 plus 3 is 24. 0 plus 0 is 0. 6 plus 0 is 6. 15 plus 3 is 18. Answer can be fraction also. So divide by 7. Then we'll get y is equal to 24 by 7. Then 0. 6 by 7. See, 0 by 7 is 0, okay? Then 18 by 7. It's not that always you should get the answer in integers. It can be a fractional answer also. Now left to you. Either you can substitute in equation number 1 or 2 or 3 or 4. You will get the same value. Or you can make any one of the multiple. Means I mean to say, since I want to find x, you can make y multiple same and get the answer. Nothing but multiply by 2 here. Then minus 2y plus 2y will get cancelled and get the answer. That will be your assignment. You have to find the x value similarly. And how to know whether your answer is correct or not? Substitute whatever x and y value you got here in the left hand side. On simplification, you should get the right hand side for both. Only then it is correct. Okay. So it also means that if option is given for both x and y, in place of solving, you can just substitute here the option which is giving correct for both the equation. That's the answer. Okay. Now let us move on to this. Before I move on to this, I would like to discuss because next problem I'm going to take in general for your complex number. Don't forget, let us have some small note here. Small note here. Coming to complex number, we know that imaginary unit I is root of minus 1. We denote root of minus 1 by I. And let us try to talk about the powers. I power 4n is always 1. I power 4n plus 1 is always I. I power 4n plus 2 is minus 1. I power 4n plus 3 is always minus I. Let you remember all this, where surely n is any natural number. If it is negative, we can either take it to denominator or numerator depending on where negative is there. It's recording, no? Oh, yeah, thank God. Now having this, let us take up a problem solution of this. If for a matrix A square is equal, A square plus I is equal to 0 matrix, where I is the identity matrix of order 2, then A is, so they are saying I is of order 2. So see, since they said I is of order 2, A square plus I is equal to 0. Addition is defined if both matrix order is same. Since I is of order 2, A is also of order 2, A square is also of order 2 only. Now, since I want to find for A, so if I take A square and transpose this here, I'll get minus I. Nothing but I'll get minus of 1 0 0 1 identity matrix. Take negative in scalar multiplication, minus 1 0 0 minus 1. So here I want that matrix. First you can see diagonal matrix. For diagonal matrix, I have to choose A here such a way that if I square this, I should get what? Minus 1. First of all, you see this is a diagonal matrix. at the beginning we discussed this concept today. In particular, it's a scalar matrix as well. So A should be which matrix? First of all, it should be a diagonal matrix because A square is diagonal. So here 0, here 0. And since here -1 is there, I have taken square. So should be I only here. Why? What is I square? See carefully here. If I put, see n can be not, so you can take whole number better. N is equal to 0 as soon I take, see carefully, n equal to 0, or wait, let it be a natural number only, because I power and the remainder. Okay, so this is the remainder. This remainder you have to see I square. I square is what? -1. So because I power, see the logic is this. This will be becoming, for example, 4n into I. For I power 4n is 1. So 1 into I is I. That's what we got. 1 into I is I. Similarly for this also, no, 4 I power 4n into I square. I power 4n is what? Let's write it here. I power 4n plus 2 is same as I power 4n into I square by law of exponents. I power 4n is 1. And what is I square? -1. So answer is -1. That's what we got. So as soon you express in terms of power of 4, see the whatever the addition is there. So anyway, here it is 2. I square is -1. So that's what you can see, that if I go for A square from here, then this each will be what? How to go for diagonal matrix multiplication? Whatever power we raise, you have to raise for the diagonal as well. Then what you will get? -1, 0, 0, -1. Correct? No, that's what we wanted. So A is diagonal matrix with the diagonal element imaginary. Option B is correct. Okay, otherwise you could have just went to the option. As soon we square each of this is anyway all a diagonal. This will be 1 square, 1 square, 1 itself, which is not going to be which matrix? This matrix, correct? Now, but when you square this, I square -1. Here it will be -1. Let us do it. Let us do that alternate method. For all this, find A square to match with this. So A square, when I do, since all are diagonal, just I have to square the what? Diagonal element. 1 square, 1 square, both are 1 only. And this is not matching with this, so option A out. See this one, I square. What is I square? -1. So this will be -1, 0, 0, -1. Yes, it's obeying this. So option B is correct. If I go with this, I square is -1, 0. Okay, then there's no problem with this. 1 square is 1. There's no one matching with this. So option C is out. Similarly, for option D, -1 whole square will be 1, then 0. Again, -1 whole square will be 1. It's no one matching with this. Option D is also out. So only option B is correct. So both the ways we have met. Okay, make a note. Okay, dear students, let us move on to a problem where you have got imaginary roots. Just now I mean to say imaginary number I. So just now, the previous problem we just took the concept. Now I have taken two problems, one in general case and then a particular power is raised. And here be careful, we should not forget at the beginning of this lecture, I mean to say when before studying first problem, I talk about how to evaluate diagonal matrix of any power. So since this is a diagonal matrix, very easily, when I want to find a power 78, as soon we see a big number, how to multiply 78 times? No, not at all. No, there is no need to get panic. Since a diagonal matrix, I have to just raise the same power for diagonal elements. Now comes the problem. Before I go ahead, since even power is there, this negative will become positive. Now how to evaluate? See, there are two ways for you. One is using this logic of 4n plus 1, 4n minus, 4n plus 2 and 4n plus 3. The simple, as soon as I take n is equal to 0, I will have this fact. What? I square minus 1, I cube is minus I power 4 is 1, I remains I only. Okay, now what logic? Listen carefully. After this fourth cycle, now I power 5 will be back as I itself. Okay, you can see here I power 5 is same as I power 5 plus 1, sorry, 4 plus 1, 4 plus 1, which is same as I power 4 into I power 4 is 1 into I will be I itself. It will repeat. So what I'm saying, no, divide whatever the power is there by 4. Okay, and try to see the remainder that will give the answer. Now see 78 when you divide by 4, what is the remainder? So here you see 4 ones are, I just divide this 4 ones are 4, borrow 3 here, 4 nines are 36. So since I got 36, so remainder is 2. Remainder is 2. So only remainder. So I repeat again, 78 is 4 into 19 plus 2. 4 into 19 is 76. Check it out, 436. Yeah, plus 2. So this remainder will decide the things. I square 0 0 I square. What is I square? Minus 1. So write down minus 1 0 0 minus 1. Which option? Option C. Job done. Now following, no, let's suppose before I take that problem, okay, first we'll take this problem. If A is equal to this, A power 4n against a diagonal matrix, so A power 4n is, when I raise the power, it's a diagonal matrix, so I can just raise the power. What is I power 4n? I power 4n. That's what I'm saying. No method is no. I want only that method. I cannot be choosy. I power 4n is 1. So wherever I power 4n is there, what? 1. So what is the value of this? Which option D is correct. Now let us frame one question where power is not 78. It is more than some more digit. See, question number 47 on spot will frame one question. A is equal to, let's suppose I'll take the same. Okay, but the question is now we have to find A power 103,897. Enough, no? Enough. Let us see how to do this. See, since this power is there, so I have to raise the power because a diagonal matrix. Don't forget, no calculator. Listen carefully. Very easily we can get the value of this. No need to divide the entire number by 4, the logic which I gave here. Okay, and one more thing, even though we have a minus, okay, let's write minus, but now power is odd, so minus will come out. Okay, now see carefully what's going to happen. I power 103,897. Only take 2-digit number, nothing but unit and ones digit. Only this enough. Don't take the remaining. Just you divide by 4 and the remainder. I mean to say whether you have got more than 2-digit or 2-digit. Only focus on what? 2-digit number. If power is positive, if negative, take it down. Okay. Now just see 97. If I divide by 4. 4 ones are 4, 4 twos are 8, borrow 1. So 4 fours are 16 plus 1 will give that answer, correct? Check, 4 fours are 16. Yes. So we will get it to be I power. This will decide the ultimate. I power 1 is what? I itself. So the answer of this will be I power 1, 0, 0. For this you understand. First minus will come out because odd power. And for that we have 103,897. So minus as it is, I power this we came to know this I. So it will be what? Minus I to be the answer. I hope this point is clear. Okay. Just you have to divide the unit and 10 plus number by 4. Even if you have got such a big number. Okay. Make a note of this. Okay, Naseer, be careful. Okay, let us proceed. Okay, action. Okay, so we have to divide. It's a huge number, but Just concentrate on the last two digit, that is 100, sorry, last two digit, that is unit and 10. If I divide 97 by 4, as it is a cycle of 4, and we divide, just see, 4 twos are 8, then borrow 1, 4 fours are 16, correct na? Plus 1, 4 into 4, 16, 4 2 is 8, 9, then plus 1. So the remainder is 1. So we are going to have this one to be I power 1. And be careful, since power is odd, what is going to happen here? Here, minus will be out and I power 103897. Due to which, since 97 by 4 remainder is 1, so this value will be again I power 1, then the remaining two elements as it is. That's it. So I can see whatever high power is there, no problem. Only last two digits you are going to concentrate, divide by 4 and take the remainder, and then you are going to have either I power 1, I power 2, I power 3 and I power 4. So all the powers are given the values, okay. This is about in case we have complex numbers. Fine. Let us suppose that if you have got a power, no, inverse, the power is given, then here I power will be negative. Then take to denominator, then apply. Don't try to apply directly. Then this logic will not work, okay. Kindly make a note of this. Dear students, before moving up to the next problem, let us try to understand one concept from complex numbers, that is cube root of unity. We will be using shortly in our problems. So let us take one note. So cube, for a while, mic. Yeah, cube root of unity. Let us understand this concept first and see when I take determinants, no, again this will be coming nothing but square root of minus 1, root of nothing but square root of unit means minus 1, yeah, root of minus 1, then cube root of unity. I would surely, want to go with the problem. Again, I should not re-discuss this concept. So make sure it should be crystal clear for you. Write in your notebook, maintain at least when you start the chapter, before writing the questions, leave 3 to 4 pages empty. As soon as I give the concept, let you have all the concept together, okay, so that you know for this chapter these are the concepts, you should be crystal clear, okay. Now let us move on. Cube root of unity, cube root of 1. I want, what is cube root of 1? Yes, you will say it is 1, but before we say that's the only one root, is it this is the only one root, is a question mark. For that, on cubing both the sides, just see carefully, on cubing both the side ng, we will have x cube is equal to 1. Power is 3, so it's a polynomial. I mean to see, yeah, it's an equation where the degree is 3, number of root depends on highest power. Since power is 3, there should be 3 roots, but we have got only one root, which is a real number. It also means that the other two roots will be complex. The other two root which is there, if I simplify, we get this. Then I think better I will derive the result for you. See carefully. X cube, if I transpose this, I'll get minus 1. See, 1 I can write as 1 cube. This is of the form a cube minus b cube, which is nothing but a minus b into a square plus ab plus b square. So if I compare, in place of a we have x, minus minus get balanced, in place of b we have 1. So if I substitute here, I'll get x minus 1 into x square plus, see, a into b, x into 1 will be x, plus 1 square is 1, is equal to 0. So product of two factors, I can equate each one of them to 0. Here we get x is equal to 1. Yeah, one of the root we got. What about the other root? See carefully. Here, this is a quadratic, you cannot factorize. So we are going to use the formula ax square. First, let us compare with the quadratic equation. So x square multiple a, x multiple b, and constant c. All if you see x square multiple is 1, x multiple is 1, and the constant is also 1. So a is equal to b is equal to c, all are equal to 1. If you use see the method formula, x is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. So we are going to have substitute. So all ABC are 1. So minus 1 plus or minus root of 1 square minus 4 into 1 into 1 divided by 2 into 1. Okay. So what we are going to have? We have one more marker. Fine. X is equal to minus 1 plus or minus root of, see carefully, 1 square is 1, minus 4 into 1 into 1 will be minus 4. So 1 minus 4 divided by 2 into 1 is 2. What is 1 minus 4? Minus 3. And I can write root of minus 3 as root 3 into root of minus 1. And this is nothing but root 3, and this is nothing but iota I. So we'll get minus 1 plus or minus root 3 I divided by 2. Root is only for 3, not for I. These are the two imaginary roots for this equation. I mean to say. Okay. So this we are going to denote as omega minus 1 plus root 3 I by 2, and omega square for the second root. See, just for namesake we didn't do omega square. If you square on both the sides, you will get back this only. Okay. And from here, some important note to be remembered. What? Since any number satisfying the given equation, only then, if any number satisfies the given equation, only then we say it is a root. For example, you can say x is equal to 1, put here, 1 cube is equal to 1 itself. Similarly, when I put omega here, we are going to have omega cube is equal to 1. Be careful, omega cube is 1. You cannot take cube root on both sides and say omega is equal to 1. Omega is never equal to 1. It is this. Okay. Next, this also means that if I just come back to this, this is the equation from which we got this 2 root. If I substitute omega is equal to x is equal to omega here, we will get omega square plus omega plus 1. This part. Okay, that's what this here is equal to 0. This will be a very useful result, both of this, to solve the problems. Some other thing, okay, one more thing. This is also a cycle of 3. I mean to say, whenever you have got omega 3, omega power 6, omega power 9, all this will be equal to whatever omega power, I mean to say, multiple of power is multiple of 3, then the value is always equal to 1. Okay. Let you have this, and then omega power 3n plus 1 is same as omega power 3n into omega. Omega power 3n is what? 1. 1 into omega is omega. So again, you can see same like I power. No, I said remainder will decide. Here the remainder is 1. The same power has come here. Similarly, if I have got omega power 3n plus 2, similarly, I can just use law of exponents. I can this as omega power 3n into omega and omega square. I mean to say omega power 3n is what? 1 into omega square, nothing but omega square itself. Again, you can see very clearly that we are having whatever the remainder is here, that is the resultant. Now, you may ask, what about omega power 3n plus 3? See, if I talk about omega power 3n plus 3, it's what? Multiple of 3. Multiple of is always what? 1. Okay. It's just going to repeat the cycle. Make a note of this. I discuss in detail so that in determinants also when I use, I can just go ahead and complex number when I take, I expect that this should be remembered by you. Okay. Make a note of it. Dear students, now let us take problems on cube root of unity. So if 1 omega square are cube root of unity. See, like this we have to state. Just seeing omega, you will not think as cube root of unity. It should be mentioned in the question. Then we have to find a power 94. Purposely I have taken the power, no, which is something, no, not routine type. Okay. As I said, no, we should be ready for all. Now, a power 94 being a diagonal matrix, just I have to raise the power. Now listen the logic. Now 2 into, correct, no, 94. 2 into 94. Yes, don't forget we are going to use this logic. A power m whole power n will be a power m into n. So it is not something like 2 power 94. Okay. Now see carefully. Omega power 94, 0, 0, omega power 2 4s are 8, 2 9s are 18. We have to simplify. Don't think of dividing this one by 3. Simple logic. We know when do we say a digit is divisible by 3? Sum of the digit should be divisible by 3. Sum of the digit, correct? So 9 4 is there, no? So add 9 plus 4, how much? 13, correct? It is not divisible by what? 3. No problem. Now you divide 13 by 3 and see what is the remainder. So what you are going to get? 3 3s are 9, 3 4s are 12, 3 4s are 12, correct? No? So 12 here, 3 4s are 3 4s are 12 plus 1. Remainder is 3. Remainder is 3. So it is omega power 1. So I hope this is clear. Omega power 94, it will be same as omega power 1, the remainder. And not to divide 94, take the sum and finish it out. Now come here, 188. Correct? Now 188. Let us take that one. 188. Sum this. 8 plus 8, 16. 16 plus 1, 17. If I divide this one by 3, what is the remainder? 3 5s are 15. 3 5s are 15 plus 2. Correct? No? So 2. Oh, omega power 2. That's it. So omega power 1 is omega. Yeah, this option D is correct. Job done. Simple. Okay. This, no, just logically thinking, no, it will just arise. Now, 49 question. If 1 omega omega square are cube root of unity, then we have to, if this matrix is equal to this matrix, then a square plus b square value we want. Just see where is a and b present. B is present here. A is present here. So A is present in the location A11. A11 is here and here. Only take that. Don't add everything. So when I'm going to add corresponding element, 1 plus omega plus A is equal to 0. Okay. Next, B is present here. This location is A22. Yeah, A22. A22. So minus B plus 2 is equal to 1. So solve from here. B you can minus B you can transpose the right hand side and 1 in the left hand side. 2 minus 1 is equal to B, or B is equal to 1. Next from here, A1. So A is equal to 1 plus, I mean to say A is equal to, transpose this, minus 1 minus omega. Yes, fine. Yes. Now we have to find A square plus B square value. Simple. Let us find one by one. Pay attention. Listen carefully. Can I take here minus common? So I'll get 1 plus omega. So I want A square plus B square. So we are going to have minus of 1 plus omega the whole square plus B is 1. But 1 plus omega, I could have done here only. What is 1 plus omega? See this careful relation here. From here you see. What is 1 plus omega? Can I transpose omega square? The other side will get minus omega square. So I can directly write this one to be what? Minus omega. 1 plus omega is minus omega. So see carefully here. Already 1 plus omega is there. So minus omega square. Minus to minus plus, I'll get omega square. A value is omega square. Let us write that one here. Let us not go for so much calculation. So what I'll get? What is A value? Omega square. So omega square. The whole square. First A value is omega square, so I wrote A value to be omega square, then whole square plus B square, B value is 1, so 1 square, 2 2s are 4, omega power 4 plus 1, omega power 4. So this is same as what? 3 plus 1 plus omega. So remainder is 1 here. So I'll get omega plus 1. So the value is omega plus 1. Option C is correct. Option C is correct. Okay. So let us move on to next. Make a note of this. Okay, let us move on to next problem. If A, B, and C are the matrices with the assigned order, then the product is possible only when. See, here there are three matrices given to us, and as soon as we see three matrices, associative property will be there in our mind, because at a time we can multiply two matrices. Even at a time we can add or multiply two numbers, correct? Now, whether the bracket is given for BC or CA doesn't make any difference, because associative is always true. So now let us take B. B order is N cross P. C order is P cross Q. First of all, since there is no sign, it means multiplication. For multiplication, have I copied correct? C is P cross Q. Oh yeah. For multiplication, number of rows, I repeat, for multiplication, number of column of the first matrix and number of row of the second matrix should be equal. Yeah, both are P and P. So these two are equal, no problem. Now, let us suppose after multiplication, we got from matrix D, B into C, some matrix D, A as it is. So the order will be now N cross Q. What is matrix A order? M cross N. If at all this matrix multiplication exists, number of column of the first matrix and number of row of the second matrix both should be same. Nothing but Q should be equal to M. Q should be equal to M. Only then this multiplication will exist. Q is equal to M. Yes, option A is correct. Okay. Let us suppose they could have asked what could be the order after multiplication. Then the order could have been N cross N only. Correct now? Fine. Now let us come to the next problem. If this E, don't forget what is E first. Let's read the question. This is equal, then values of X and Y respectively. They are given the values to answer. Now see, E is an irrational number. The way we have pi. Pi approximate value is 3.14. Irrational number. Similarly, E approximate value is 2.7. Both are irrational number. We have to find the value of X and Y. E is a scalar, multiply in. How we are going to multiply? E should be multiplied to each and every term. So we are going to have E power X into E. Then again here also E power Y into E. Then here E power Y into E. And here also E power X into E. Let us write this E bit more bigger. Is equal to right hand side. Now recall from school days, law of exponents. A power M into A power N is A power M plus N. So if bases are same under product, we can add the power. We can see the thing is happening here. Very easily you can see power of this is 1. So bases are same, we can add the power. We will get E power X plus 1 this term. And since I have got equality, I have to equate to the first corresponding term. So when I equate to 1, okay, this is E power X plus 1, not Y, sorry. Yes. Similarly, you can either equate this also. Here, bases are same, we can add the power. So you get E power Y plus 1 is equal to 1 again. We also know one of the property from school days that A power 0 is 1 provided the base A is not equal to 0. So E, as we know, it is approximately 2.7. So base is not equal to 0. So we can write 1 as E power 0. Similarly, this one also E power 0. Now, since bases are same, we can equate the power. So equate the power here. X plus 1 is equal to 0. This implies X is equal to minus 1. Again, equate the power as base are equal. So Y plus 1 is equal to 0. Nothing but Y is equal to minus 1. So both X value and Y values are minus 1. That is there in option A. You can see both are equal. Now let us move on to the next question. If the matrix given here is commutative with the matrix this, then. So if at all it is commutative with this matrix, then what could be the condition they're asking? So solution. Let us assume for a while. Okay, directly write. So commutative means this matrix. If I interchange also, it should be same. I thought I'll take capital A, capital B. Why unnecessary to have some more alphabets? Ah, come on. Now, if it is commutative, have we written the elements correctly? Yes. Now, what should be the condition? So, first multiplication, row versus column. So, when I multiply row versus column, see carefully. A into 1 is A, plus B into 0 is what? 0. Let us have the corresponding element here also. Row versus column, correct? 1 into A is A, plus 1 into C is C. Okay. Now equate that. A plus 0 is what? A itself. No. So equate this one. A plus 0 is A is equal to A plus C. A will get cancelled. C is equal to 0. So one such condition is C is equal to 0. Do we have in the option? No. Okay. Let us continue. Let us multiply row and the second column. A into 1 is A. Then B into 1 is B. Again here, first row, second column here. 1 into B is B, then 1 into D is D. Again, if I equate this one to each other, corresponding element, we are going to have A plus B is equal to B plus D. On either side, what will get cancelled? B will get cancelled. A is equal to D. A is equal to D. So we are coming very close to this. Okay, let us see. Next row, okay, second row and first column. C into 1 is C. D into 0 is 0, so I'll get C plus 0, nothing but C itself. Correct? No. Now you multiply second row and first column. 0 into A is 0, 1 into C is C. Oh, C is equal to C. Okay. We are not getting any benefit from this. Last one. This second row, second column. C into 1 is C, plus D into 1 is D. Then here 0 into B is 0, 1 into D is D, so 0 plus D. Okay, so again, if you see very carefully, that here equated C plus D is equal to D, or C is equal to 0. So C is equal to 0 and A is equal to D. C is equal to 0 and A is equal to D. We are nowhere getting as such any relation. A, B, C, D. Okay, 1. Okay, dear students, I just checked the question. Here, this is C is equal to 0. Okay, C is equal to 0. So option C is correct. Hello, I copied the question wrong. Let us suppose in examination like this we get, surely we'll have a grace mark. You are not going to change the options. Okay, kindly make a note of this. Dear students, let us move on to next problem. Question number 53. If A is a 3 by 3 skew symmetric matrix with real entries and trace of A square equals 0, then we have been given the option that is matrix A is 0 matrix, or 2 times of A is identity matrix, A is an orthogonal matrix, none of this. Now here, let us recall some of the things here. What do you mean by trace? Trace means sum of diagonal elements. And what do you mean by orthogonal matrix? A square matrix is said to be orthogonal if A into A transpose same as A transpose into A is identity matrix. Nothing but the transpose of a matrix is inverse of matrix A. Okay. Now having this information, let us move on with the solution. Since they said A is a skew symmetric matrix of order 3 cross 3, don't forget diagonal element of this should be 0. Hope so this recording. Yeah. Next. Now see here, if I take A here, this corresponding element should be what? Minus here. If I take B here, the corresponding element should be what here? Minus B. And if I take C here, then the corresponding element should be what? Minus C. Now, we want A square. If it is A square is 0, then what can be matrix here? So since they are saying A square is equal to 0 matrix, A square equal to 0, let us write A square means multiplying A twice. So let us write down. So 0, this is minus B bit top, okay. A minus B, then minus A, 0, minus C, B, C, 0. Okay, now again going ahead, 0, A minus B, then minus A, 0, minus C, then B, C, 0. This is equal to null matrix. Now we know how to multiply two matrices. We have to multiply row versus column. So let us multiply. So when we are going to multiply row versus column, see carefully, 0 into 0 is 0, then A into minus A will be minus A square, then minus B into B will be minus B square, okay. Then if we go for the second column, give a space, 0 into A is 0, A into 0 is 0, minus into BC I will get, okay. Then again if I go for the third column, 0 into minus B is 0, A into minus C is minus AC, then minus B into 0 is 0, okay. Next is equal to, let's have second proceed, minus A into 0 is 0, A into 0 is 0, minus into CB, okay, nothing but minus BC. Now moving on to the next column, minus A into A will be minus A square, then 0, minus into plus is minus C square. Then moving to third column, minus into minus plus AB, 0 into minus C is 0, minus C into 0 is 0. Coming to the last row, B into 0 0, C into minus A is minus CA, then 0 into B is 0, then B into A is AB, C into 0 0, 0 into C is 0, okay fine. Then B into minus B is minus B square, B, okay, C into minus C is minus C square, 0 into 0 is 0, okay. Now see carefully, since this is a 0 matrix, I should have each and every element to be 0. Don't forget, the 0 matrix and identity matrix order depends on the context. Since this is a 3 by 3 matrix, therefore 0 matrix also 3 by 3. Now we are going to equate each one of the term and we want to know what is matrix here, correct? Now see here carefully, since I have got 0 matrix here, I have to equate each of this term to 0. If I do so, let us complete here. If we do so, see carefully, minus A square minus B square should be equal to 0. So minus A square minus B square should be equal to 0. Multiply by negative sign, you will get A square plus B square is equal to 0. Okay. Next, you can see this also, no? This diagonal element, if I equate to 0, again we will have minus A square minus C square is equal to 0. Multiply by negative sign, we will have A square plus C square is equal to again 0. Lastly, if I go with this and equate with this, so we are going to have minus B square minus C square is equal to 0. This implies B square plus C square is equal to 0. Similarly, we can equate the means this element, B into C is equal to 0, A into B is equal to 0. There also we are getting one insight, what? If minus B into C is equal to 0, if product of two numbers is equal to 0, any one should be 0. So either B should be equal to 0 or C should be equal to 0. That's what you can see from the remaining also. And from here also you see, when we say sum of the square is equal to 0, see sum of the square can be either 0 or positive. But since each term have got a square and it is plus sign in between, surely if at all this should be 0, one thing is very clear, A should be equal to, B should be equal to, C should be equal to what? 0. This we can see from here also. Now when I put this values in equation number 1, that is matrix A, if I put in equation number 1, then the matrix A will reduce to wherever A, B, C is there should be 0 now. So if I just substitute, I will get a null matrix or a 0 matrix. That is the option A. So it is a null matrix. I hope this is clear. Fine. Now from here we will be taking some previous year question paper problems. I mean, it's the previous year, yeah, Kcet problems. And here I have started with 2016. Now, question says, if A is a matrix of order m cross n, let us write down the data here. A is a matrix of order m cross n. We are not in PUC to write each and everything. So just below the matrix, I'll be adding the data. So they said order is m by n, so I wrote m by n here. And B is a matrix such that, okay, B is a matrix such that A into B transpose, fine, and B transpose into A, both are defined. Then the order of matrix B is, okay, so let us assume that the matrix order B is P cross Q. Okay, don't forget, when you take transpose, order will change to row, and I mean to say, whenever you take transpose, order will change. Row will change to column and column will change to row. So here one thing is very clear from this, that B transpose, if I talk about, P cross Q will be Q cross P, because P stands for number of rows, Q stands for number of columns, it will get exchanged. Now here A is of order m cross n, B transpose is of order Q cross P. So now recall, when do we say matrix multiplication exists? Matrix multiplication exists if number of column of the first matrix and number of row of the second matrix are equal, nothing but n should be equal to Q. Similarly, for B transpose into A, B transpose is Q cross P and A is m cross n, and again here number of column of the first matrix and number of row of the second matrix should be equal, nothing but P should be equal to m. Now we can comment about the order of the matrix B. Therefore, the order of the matrix B, which we have assumed to be P cross Q, is now B will be P. What is P? M. Cross, what is Q? N. So the matrix B order is M cross N. M cross N is there in option D. So option D is correct. Now one note I want you to take. What? Let us suppose that question was, what is the order of B transpose? Then very simple, what are the answers I got? Just extend the row and column n cross n. Okay. If they ask the transpose of B order. Okay. Fine. So kindly make a note. Dear students, let us move on to the next problem. As I said here, that as mentioned, previous year Kcet questions we are solving, and I am continuing with the numbers, but I have mentioned the year in which the question has appeared. So in 2019, question says, if this matrix is given, then find matrix B. Be careful. Here you have got B transpose and you have got A transpose. We want B, and surely you have to eliminate A. So since here I want B, let us try to make this B transpose B only. See, we know that if we are going to take transpose twice, we get back what? The same matrix A. So having that logic, if I take this as equation number 1, let us take transpose on both sides in equation number 1. I hope it's recording. Yeah. So equation number 1 will change to, now see, when applying transpose, as you know, for some, transpose can be splitted. I mean to say, A plus B, the whole transpose is equal to A transpose plus B transpose. So here you see 3A transpose, then plus 4B transpose, the whole transpose. If applied twice, I'll get back B is equal to, now here this transpose, the transpose for this first row will become first column 7 minus 10, then 17, and the second row will become second column 0, 6 and 31. Now coming to this, see here I'm just going to rewrite as it is. 2B, I'll write with B here, plus 2B it is, then minus 3A transpose. So minus 3A transpose is equal to this matrix minus 1, 18, then 4, 0, finally minus 5 and minus 7. Now just we have to simplify. Here already signs are opposite for A transpose. This will get cancelled. 4B plus 2B will be 6B is equal to, now coming to addition of two matrices, we know how to add. Corresponding element we have to add. 7 minus 1 will be 6. 0 plus 18 will be 18, minus 10 plus 4 will be minus 6, 6 plus 0 will be 6, 17 minus 5 will be 12, 31 minus 7, this is 7, mind it, minus 7, it will be how much? 20, is it 4? 24, yes, correct. Now since I want only b, divide by b. If you divide by, I mean to say 6, not b, divide by 6 on both the sides, we will get b is equal to, yes, if I divide by 6, I'll get here 1, then 6 3s are 18, minus 1, then 6 1s are 6, 6 2s are 12, 6 4s are 24. And this is there in option B. So option A. So option A is correct. Okay. Let us suppose they asked A. Then what we will do here? We are going to take transpose, right, for this matrix, and then we get A here. Correct. Then we change the sign and try to multiply for B, make the multiple of B same. Okay. Fine. Otherwise, after finding B, you can substitute here, get A matrix. Now coming on to question number 56. This is asked in the year 2020. Question says if A is equal to this, be careful, this is not a diagonal matrix. For diagonal matrix, I mean to say for identity matrix, this element here should be 1. Now we want A power 4. First, let us try to find A square. A square is A into A. So coming to this, 0 0 1 0 1 0 1 0 0, again here 0 0 1 0 1 0 1 0 0. We know how to multiply two matrices, row versus column. So if I multiply the first row with the first column, 0 into 0 0, 0 into 0 0, 1 into 1 1. Again multiply with the second column, 0 into 0 0, 0 into 1 is 0, 1 into 0 is 0. Yes. Okay, I am directly adding the values. Okay, 0 into 1 is 0, 0 into 0 0, 1 into 0 0. So 0 plus 0 plus 0 is what? 0. Then second row, 0 into 0 0, 1 into 0 0, 0 into 1 is 0. So sum of the element will be again 0. 0 into 0 0, 1 into 1 1, 0 into 0 is 0. So I'll get again 1. 0 into 1 is 0, 1 into 0 is 0, 0 into 0 is 0. Next, lastly this row, 1 into 0 0, all 0. Then this is also 0, and ultimately what is this identity matrix? Now that's what concepts are so important. Now there is no need to further multiply like this. Here we got one relation that A square is equal to identity, and I want A power 4. So multiply by A power 2 on both the sides. Why? I want A power 4. So if I multiply both the sides, A power 2 into A power 2 is equal to I into A power 2. But what is A power 2? Here I. So here you see, this is A square, and A square will be A power 4. And here I as it is. A square is again I. I into I is what? I square. But what is identity matrix power n? It's always the identity where, okay, for this. So I'll get A power 4 is equal to I square is what? I itself. So A power 4 is identity matrix, that is then option blue. Option B is correct. I hope this is clear. Kindly make a note. Okay, dear students. Okay, which year is this? 2023. Okay, this is 2023. Okay, fine. Now let us go ahead with the problem. Question number 57, asked in the year 2022. If A is a matrix of order 3 cross 3, then A square inverse is. Here we call the property that A power n, the whole inverse, is same as A inverse whole power n. So because of this, n is what? It can be any natural number. So in place of n, we have 2 here. So directly without any trouble, we can write the solution that A power 2 whole inverse is same as A inverse whole power 2. which is there in option C. So option C is correct. Okay. Now coming to 2023, here this was asked, and question 58 it is, if A and B are two matrices such that AB is equal to BA and BA is equal to matrix A, then what is A square plus B square? Solution. First, let us consider this part. I want A square. For that, no, let us consider matrix AB, which is equal to B. Let us multiply, post multiply by A, matrix A on both the sides. Then we will have A, B, post means after, pre means before the matrix, post means after the matrix. So I have just multiplied matrix A. Now this is our equation number 1. This is our equation number 2. Now see carefully, we know that under matrix, no, what is true? Associative property is true. So I can rewrite this one as A, then here BA is equal to, what is BA here? BA is matrix A. Fine, I can write. Similarly here also, again BA is what? Matrix A only. From equation number what? 2. What is A into A? A square is equal to A. Very clearly we have got that. A square is what? A. We want B square also. Similarly, on the same way we can do, and you will get B square is equal to B. Now what they want? They want A square plus B square. Come on, find it here. A square plus B square. What is A square? We got A. What is we got? B square. What we got? B itself. So I can just substitute A plus B. Okay, that is there in the option blue B. Okay, quite easily done. Kindly make a note. Matrices, as you know that we are dealing with Kcet, and we are targeting 55 plus on 60. Actually speaking, I should say 60 only, but extra precaution, nothing else. Now coming to question number 59. If the if matrix A is of 2 by 2 order, where Aij is given with this condition, then we have to find A square. So see, this is a very elementary level. It is talking with respect to what? Location. Elements are given, I have to find the matrix A first. See, they are saying I not equal to J, nothing but non-diagonal element, and matrix is of order 2 by 2. So 2 by 2 matrix if I talk about, and if at all you are having confusion, very simple. This is first column, second column, this is first row, second row. So this will be A, 1, 1, first row, first column. This will be A, first row, second column, A, 1, 2. This will be second row, first column, A, 2, 1. This will be second row, second column. So we have got a 2 by 2 matrices. Now they are saying if index I and J are index, if they are not equal, nothing but this 1, 2 and 2, 1, the element is 1. Okay. So the non-diagonal elements are 1. And if it is equal, I and J is equal, nothing but diagonal element, it is 0. Diagonal element, yeah, it is 0. Yeah, we have framed the matrix here. Then what we have to find? A square. Fine. Multiply, how to get A square? Multiply matrix A twice. So A into A. So we are going to have 0, 1, 1, 0. Then 0, 1, 1, 0. Multiply now. Row versus column. 0 into 0, 0. 1 into 1, 1. Then second column, 0 into 1 is 0. 1 into 0 is 0. Then coming to second row, 1 into 0, 0. 0 into 1, 0. 1 into 1, 1. 0 into 0, 0. So 0 plus 1 is 1. 0 plus 0, 0. Then 0 and again 1. So what we got? Identity matrix. A square is identity matrix. Option A is correct. Okay. I hope this is clear. Kindly make a note. Dear students, let us move on to recording. No? Yeah. Yes. Dear students, let us move on to question number 60. Question says A and B are 3 by 3 matrices such that A transpose is equal to minus A, which is a definition for A to be what? Skew symmetric. Correct? For a matrix to be skew symmetric, if I take transpose, I should get negative of the given matrix. And B transpose is equal to B. This is the definition for symmetric matrix. then the matrix lambda into AB plus 3 times of BA is a skew symmetric matrix for which values of lambda? This is option D here, D. So now, see whether it is symmetric or skew symmetric, transpose is mandatory. Transpose is mandatory. Let us take this matrix, that is lambda times of AB plus 3 times of BA. Let us take as some other matrix C. Now I will take transpose on both the sides. On taking transpose both the sides, I'll get this. Recall the property. See, our properties will be a shortcut for us. Without properties in matrices determinant, we cannot think of surviving. We have to memorize what is the property. As a 5 marker we have did in PUC, A plus B whole transpose is A transpose plus B transpose. When you take the transpose, the order will not change. Even for subtraction also, same thing is going to happen. So here, this I can take as one matrix and this is the other matrix. In between I have a plus. So if I apply the transpose lambda A into B, the whole transpose plus 3 times of BA, the whole transpose. Now you see, lambda is a scalar multiplied to AB and 3 is a scalar multiplied to BA. So again recall, whenever you have got any scalar lambda, or I can say K scalar into matrix A, when I take transpose, the scalar is unaffected. So when I take the transpose, lambda will remain lambda into A into B whole transpose. Then 3 will remain 3, B into A the whole transpose. Next, now I want to take transpose for both. Recall, A into B whole transpose is the reversal law. The order will change. Matrix A is first matrix, B second matrix, so it is second into matrix first. So here the order will change. Lambda times of B transpose into A transpose plus 3 times of this will be B. This is first matrix B and second matrix A here. So A transpose into B transpose. But in the question, since they are given A transpose equal to minus A and B transpose equal to B, so I can substitute here lambda. B transpose is B and A transpose is minus A. Similarly, plus 3 times of A transpose minus A and B transpose is B. And I complete it here. Now from here, see carefully, negative is common. If I take negative out, then what we are going to have? Negative is out, so lambda BA plus, since negative is already out here, so minus into minus will be plus. So I'll get 3 times of AB. Correct? Now just try to compare this with this matrix C. Let us say this is our equation number 1. So we have got in the left hand side C transpose is equal to this. Now AB multiple is lambda, but I mean to say BA multiple is lambda, but here it is 3, and AB multiple is 3, that is here lambda. So if at all it is skew symmetric, then what should happen? C transpose should be equal to minus C. And for this to happen, for this to be skew symmetric, the lambda value should be same as 3. That's it. Or here, this lambda value should be equal to 3. So for lambda equal to 3, only for plus 3, it is what is skew symmetric. Therefore, the answer will be option blue. Kindly make a note of this. So yes, we have got for question number 60B, and this is from equation number 1, which I have taken here. Okay. Now moving on to the next question. Choose the correct answer. And this question is completely depending on the options. Option A, every scalar matrix is an identity matrix. Option B, every identity matrix is a scalar matrix. Option C, every diagonal matrix is an identity matrix. Option D, a square matrix whose each element is 1 is an identity matrix. This particular question is also asked one of the previous year in Kcet, and here this question is completely depending on types of matrices concept. Now coming to the solution of this, see here, let's try to know once go for types of matrix. Coming to diagonal matrix, what is a diagonal matrix? It is a square matrix. First of all, it should be a square matrix. in which non-diagonal elements are 0. For example, A is equal to here A, then here this is 0. See, I said non-diagonal elements are 0. So these two are non-diagonal. This is a diagonal element. Whether diagonal elements may or may not be 0, but non-diagonal should be surely 0. So this is an example for which matrix? Diagonal matrix. Next is scalar matrix. What is a scalar matrix? It is a diagonal matrix. Yeah, you heard it right. It's a diagonal matrix where as soon as I said diagonal matrix, non-diagonal elements are 0, but diagonal elements should be same. For example, if it's 5 here, this should be 5 again here. Diagonal elements are, don't forget, this is A11 and this is A22. Next is identity matrix. Recall what is identity matrix. It is again a diagonal matrix in which diagonal elements are always equal to 1 and we denote by I. So 1, 0, 0, 1. Now from here, one thing is very clear, that as a note we can have that every scalar and identity matrix are diagonal matrix. And similarly, every identity matrix is scalar matrix. So why it is so? See, for identity matrix, diagonal element should be always equal to 1, but in scalar matrix it can be any number but should be 1. So this is a special case of scalar matrix. That's why every identity matrix is a scalar matrix, and every scalar and identity matrix is a diagonal matrix because non-diagonal elements are always 0. Okay, and here one particular case is that diagonal elements should be same and here it should be always equal to 1. Now come to the option one by one. Every scalar matrix is identity matrix. No, this is a scalar matrix but is not a unit matrix. So option A ruled out. Every identity matrix is scalar matrix. Yes, that's all I commented. Every identity matrix is a scalar matrix. So option B is correct. Let's go for other option to understand better. Every diagonal matrix is an identity matrix. This is a diagonal matrix, but it is not an identity matrix. So option C is out. A square matrix whose each element is 1. See, understand this. Square matrix, for example, 2 cross 2 will take. Each element is 1. This is nowhere a diagonal matrix. Okay, and it's not a unit matrix. For unit matrix, diagonal element should be 1 and remaining element should be zeros. So this is an identity matrix. No. So only option B. It's purely concept based. Now moving on to the next, and here comes some of the other concept to be understood. See carefully. The number of non-zero diagonal matrices of order 4 satisfying the condition A square is equal to A is. I want to know how many matrices are there where it's a diagonal matrix. Not only that, it should satisfy the condition A square is equal to A. So since they said order 4, so let us take one example, means a general matrix will take, general matrix, not an example, where the order is 4. So since they said it's a diagonal matrix, non-diagonal should be 0. Non-diagonal should be always 0. Now see carefully here. Okay. Now they said A square is equal to A. At the beginning, I just gave you how are you going to take product A power 2, A power 3 for diagonal matrix. A diagonal matrix. For diagonal matrix, this is A square equal to A. For diagonal matrix, just you have to square the diagonal elements. So when I square the diagonal elements here, instead of multiplying, we have just squared the diagonal elements. So it is A square 0, 0, 0. Then 0, here it is B square, C and D here. So B square 0, 0. Then 0, 0, C square 0, 0, 0, 0 and then D square. is equal to the matrix here. Think about the same matrix. A 0 0 0 0 B 0 0 0 0 C 0 0 0 0 D. We have to find how many such matrices are possible, that it is a diagonal matrix, that to non-zero, and satisfying this condition A square equal to A. Why they have used the word non-zero also understand. Okay, now just see carefully. Now since here equal is there, when do we say two matrices are equal? Order should be same and corresponding element should be same. Here we can see the order is 4 cross 4, vice versa, 4 rows we have got and 4 columns we have got. So order is same and I can equate the corresponding element. So 0 is already equated to each other. You can see one except diagonal elements, remaining all are 0. So anyway, there is no problem with the non-diagonal element. Now for diagonal, A square should be equal to A. A square should be equal to A. If I solve for A square is equal to A, never cancel. See, A, B, C and D all are unknowns here. Don't cancel. If you cancel, you will lose one of the root. Now A is a variable for us. We have to find what are the different values of A satisfying this condition. So don't cancel A. So transpose here, we will get A square minus A equal to 0. A is common, so A minus 1 is equal to 0. Product of two number equal to 0, equal to 0. What you will get, either A is 0 or A minus 1. Write in next line, or A minus 1 is equal to 0. From here I get A is equal to 1. So I am getting two roots. Either A should be 0 and or A should be 1. The same thing will happen for this also. B square equal to B, C square equal to C and D square equal to D. Let's write it here. B square equal to B, C square equal to C and D square equal to D. By symmetry, from here, no need to solve. I can just say that B value will be either 0 or 1. C value also will be either 0 or 1. Lastly, the D value will be again either 0 or 1. So these are the numbers that can be given for matrix. Now see carefully. Here we have A, B, C, D. These values can be either 0 or 1. So we have to, only we are bothered about the diagonal element. So we have got 4 elements. So since 4 elements, now comes permutations and combination, arrangement of objects. We have got 4 boxes because 4 places we have to fill. Now the objects are 0 or 1. Correct? So here, let us suppose I want to fill for A. Here I want to fill for B. Here I want to fill for C. And here I want to fill for D. For all we have got 2 options. What? Either 0 or 1. So number of object 2. Why 2 here? Either I have to fill 0 or I have to fill 1. So here also, here also, here also. By fundamental principle of counting, I can multiply them, which says that if m events occurs if m event occurs and followed by another event n occurs, then total number of occurrence will be m into n. Now here we have got 4. So 4 events, 2 into 2 into 2 into 2 will be what? 2 2s are 4, 4 2s are 8, 2s are 16. Many will think 16 is the correct answer. Hold on, hold on. Now come, they said non-zero diagonal. See, when we got 0, in this surely 0 is also there. If I write 0 here, 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 it is again a diagonal matrix only, but it's a 0 diagonal matrix. Every 0 matrix of square order, nothing but every square matrix which is 0 matrix is also a diagonal matrix. Don't forget this. Now we want non-zero diagonal. So one such matrix is there in this. So since we want non-zero diagonal, non-zero diagonal matrix, so what we are going to do, out of 16 such matrices, it's only one matrix in which all the diagonal elements are what? 0. So I am removing that matrix. So 1 means I am removing that matrix in which all the diagonal elements are what? Zeros. So 16 minus 1 is what? 15. So option D is correct. I hope this point is clear. Okay. So slowly I am just trying to upgrade the level of the problem. Just you can think, if order is 3, what could be the answer? Order is 5. Okay, same logic will happen. One box will be less. If I say order 3, one box will be less. 2 into 2 into 2 will be how much? 8. 8 minus 1, 7 is the answer. Okay, fine. Kindly make a note of this. Fine. Dear students, let us move on to the next question. Question number 63. The total number of possible symmetric matrices of order 3 by 3 whose entries are 0 or 2. See, in NCERT textbook, we had a problem like this where it was only total number of possible matrices of order so and so 3 by 3 with 0 or 1. Answer was the 2 power 9, 5 and 2. But here we are asking symmetric matrix. Okay, now since it's 3 by 3, first let us have a matrix of order 3 by 3. Coming to symmetric matrix, recall if we have diagonal element A11, A22, A33, whatever the element we have got here, mean to say this A12, the element present here A21 should be same. Since A transpose is equal to A for symmetric, AJI should be equal to AIJ. So this with respect to the diagonal elements, there's whatever the element we have got above, same thing should be below. Again, whatever we have got here, 3, 1, third row, first column, should be same as first row, third column. This one should be same. Again, whatever we have got here, third row, second column, should be same as here, second row, third column. So mean to say that there is no need to select either the below the diagonal element or above the diagonal element. No need to select, because as soon we fix, for example, suppose this one is fixed. As soon this is fixed, as soon we are going to choose, there is no need to choose here, because as soon this is taken, this should be the same. Only there it is symmetric matrix. So it means we should be only bothered about diagonal element to be chosen and this element or this anyone. So if I just go with this part, if I go only with this part, so how many elements are there? 1, 2, 3, 4, 5, 6. So we have got 6 places. Again 1, 2, 3, 4, 5, yeah, 6. Again permutation and combination. Why 6? Why not 9? Even though 9 elements are there, because it's symmetric matrix. Whatever the element we have got, same element should be here. Similarly, whatever the elements are there here, same element should be there. So no need to choose either side. Any one side we have to choose. And the elements are 0 or 2. Okay, diagonal may need not be same. Correct? No. So here either I should choose 0 or 2. So 2 objects. Here also 2. Here also 2. Here also 2. Either 0 or what? 2. So again, by fundamental principle of counting, if I just multiply 2 into, I mean to say permutations and combination chapter, fundamental principle of counting, which says that if an event can occur m ways, following which another event occurs n ways, then the total number of occurrences m into n, product of those two. Similarly, here we have got 1, 2, 3, 4, 5, 6. So multiply, we get 2 power 6. 2 power 6 will be 2 2s are 4, 4 2s are 8, 8 8s are 64. Option blue is correct. Okay, think what could be for skew symmetric. Okay, now we have almost come to an end. Now I'm taking one topic, nth power of matrix here. There is no such topic. I have just given a heading so that whenever the powers are huge beyond a cube etc., you will understand and should remember that okay, sir discussed this concept, I have to apply this logic. Surely now just see this question, dancing 101 things. Let us try to solve the problem. If matrix A is equal to this, then find A power 16. Surely we are not going to multiply 16 times. So we are going to go for some pattern. Just see. First to find A power 2. Nothing but multiplying matrices twice. And it's not a diagonal matrix. Okay. Now see carefully. When I'm going to multiply row versus column, 0 into 0 will be 0, 0 to x will be 0, 0 and then second column now, 0 into 0, 0, 0 into 0, 0, so 0 plus 0 is 0, x into 0 is 0, 0 and x is again 0, then x into 0 will be 0, 0 into 0 is 0, hope so it is recording, yeah it's recording, thank God. So A square will be equal to what? This is a 0 matrix. Now I have to go to a power 16. See, since a power 2 is 0, I want till a power 16. So I can just multiply both the side by a power 14. Okay. Now when I'm multiplying, since one matrix is 0, whenever coming to multiplication of any two number or even matrices, if any one of the matrix is 0, product of those is what? 0 only. And here bases are same, you can add the power. So it is a power 2 plus 4 is what? 16. 0 into any matrix A or A into 0 matrix is always what? 0. Now we came to know a power 16 is what? 0 matrix. Therefore option D is correct. So what I'm trying to convey a message here is, whenever the powers are higher, we are not going to multiply those many times. We are going to see some pattern. But in this particular case, as soon we found a power 2, we just came to know 0. So whatever power it is, henceforth will be surely what? 0. Because always to get the next power, I have to surely multiply with a square. And whenever in product of two matrices, if any one of the matrix is 0, surely the product of those will be again 0. Now you see this question. If A is equal to 1, 1, 1, 1, surely it's not a unit matrix. Then A power 2017 is. So again, surely we are not going to multiply 2017 times. We are going to see some pattern there. So first, let us find A square. How to get A square? Multiply matrices A twice. So matrix A is here 1, 1, 1, 1. Again here also 1, 1, 1, 1. Now let us multiply. How to multiply two matrices? Row versus column. So here A square is equal to 1 into 1, 1, plus 1 into 1, 1. Now multiply the second column. 1 into 1, 1, then 1 into 1, 1. Similarly, from second row to first column, I'll get 1 plus 1. Again, you can see 1 plus 1. So we are going to have A square from here to be 1 plus 1, 2, 2, 2, 2. Okay. Now, since you can see here one pattern that it's always written A. So I want A only. To get A, the element should be 1, 1, 1. So if I take square means 2 common, we will get 1, 1, 1, 1. So I came to know A square is equal to 2 times of this entire matrix from equation number 1. It is A only. Now from here, let us find A cube. So multiply by A cube on both the sides, then we will have, I mean to say A, not A cube, A. Then I'll get A into A square is equal to 2 times of A into A. A into A square is A cube is equal to 2 times of A into A will be A square. A into A will be A square. But what is A square we have got? This we call reconciliation. Again, in place of going back to matrix, I have got one relation. I'm going to use the relation. Just see this. I will take this as equation number 2. So what is A square? 2A. So let's see here. 2 as it is. In place of A square, 2 times of A. 2 into 2 will be 2 square. Why I didn't wrote 4? Understand. I want this pattern. Always the multiple of matrix A is 2. Now from here, try to analyze. Analyze. So in general, what we can say, A power n is equal to, see carefully, when it is A power 2 and A power 3, you can see multiple 2 and 2. So I write 2 here. Then matrix A, matrix A. So I wrote matrix A also. Okay. Now you see the power of 2 here, 1. So when power of A is 2, power of 2 is 1. When power of A is 3, power of 2 is what? 2. So always the power of 2 is 1 less than the power of A in the left hand side. So since power is n, it should be what here? N minus 1. Now in the question they ask A power 2017. So put n is equal to 2 power, I mean to say put n is equal to 2017. So we get A power 2017 is equal to A power 2017 minus 1 into matrix A. So 2017 minus 1 will be 2 power 2016 into matrix A. So this is the value for A power 2017, which is there in option blue. Nickname for option B. I hope this point is clear. This is how we are going to go ahead for any general power, n power for matrix A. We are going to perform A square, A cube, and then we are going to generalize it. Kindly make a note. Yes, dear students, let us move on to the next problem. And you can see here we have got one relation. Okay, what we did in the previous problem, they gave matrix here, and from there we got recurrence one relation, which I call recurrence relation. Now just see, if I start with the solution with this again, a power n plus ni. Put n is equal to 1 and just see whether any option matches with that. So if I put n is equal to 1, we are going to get this one to be a plus 1 into I is I. So I got a plus I. Now check the option one by one. Okay. So for n is equal to 1, here it is identity, option A, then here it is only A. Okay. So both are rejected. Now again put n is equal to 1 here, I get I plus A, and this will be I minus A. Straightforward, I plus A, yeah, I plus A is here, option C is correct. And again this is rejected. Let us suppose that we had two options going with this, then surely I have to think of finding A square. Okay, find A square and then try to compare. But anyway, we got the answer very directly. Now come to this trigonometry. As soon as it comes, I know many students will think, oh my god, how to tackle. There's nothing. As I said, we can't be choosy. We have to be ready for each and everything. It's not like PU board exam. Important questions will be given, model papers will be given, and you have to study from there. No. Okay. Now see, if A is equal to this, then find A power 10. Surely we are not going to go till A power 10. Options are given here. First, let us try to find A square. We make it some clue. It is A into A. So cos alpha minus sin alpha, then sin alpha, cos alpha into again cos alpha, sin alpha, minus sin alpha, cos alpha. I hope it's recording. Yeah. Now how we are going to multiply? Usual way of multiplication, row versus column. Let us multiply. Cos into cos will be cos square alpha. Then plus into minus. Sin into sin is what? Sin square alpha. Now go to the second column. Now here cos into sin. Cos alpha into sin alpha. Plus into plus. Sin into cos alpha. Sin alpha into cos alpha. Done. Column multiplication. We have finished with all the columns. So I have closed the bracket. Now let us move on to second row. Minus sin alpha into cos alpha. Minus sin alpha into cos alpha. Plus into minus is minus. I don't want to write it here. I'm just writing below. Cos into sin alpha. Then minus into plus is minus. Sin into sin will be sin square alpha. Plus cos into cos will be plus cos square alpha. Now we know some of the result from trigonometric function. What is cos square x minus sin square x? It is cos 2x. We are going from right to left. We should know the formula both the ways. It's a multiple angle formula. So here the angle is x with the difference of cos square and sin square. Whatever the angle is there, double of that. Now you can see carefully. The same thing is happening. Whatever is there here. So a square will be what? This will be cos 2 alpha. Whereas you see this one, this of something, no? This of the form AB plus BA. What is AB plus BA? 2AB. Correct, no? This is A, this is B, then this is B, this is A. So 2 times of AB. So 2 times of sin alpha cos alpha. 2 times of sin alpha cos alpha. Then you see the next. Again it's the same, no? Minus 2AB, minus AB, minus BA. Again minus, I can add both the terms are same. So minus 2 sin alpha into cos alpha. This is alpha, not 2. Then this cos square alpha minus sin square alpha is equal to this formula. So again I get cos 2 alpha. Again recall what is sin 2 times of sin x into cos x, multiple angle formula. It is sin 2x. Again, right to left. So we are going to have this no change in the first term, whereas the alpha here. Here you see this is going with this. So what are the angles and double of that? So double of alpha will be 2 alpha. Again here also double of that will be 2 alpha. And here cos 2 alpha. This is a power 2. Now from here we can generalize. See carefully. When power of a is 1, see the angle. Multiples also what? Alpha, alpha, alpha. When power of a is 2, then it is 2 alpha, 2 alpha, 2 alpha everywhere. So if I say I have got nth power, then we can generalize that we are going to have cos n alpha, sin n alpha, minus sin n alpha, and then cos n alpha. In the question they have asked us to find a power 10. So in place of n put 10. I could have directly done this one, but I wrote this one to make you understand generally how to frame. Okay. So a power 10 will be, put everywhere wherever n is a 10, cos 10 alpha, sin 10 alpha, minus sin 10 alpha, and cos 10 alpha. This is there in which option? Kindly check it out. It is there in option blue. So option B is correct. Kindly make a note of this. Okay, dear students, we are with the last problem from the chapter matrices on Kcet, and this question has been asked in the year 2018. Okay, question says if matrix A is 2 minus 2 minus 2 2, then A power n is equal to 2 power k into matrix A. Okay, if this is the recurrence relation we are going to have, then what is k value? Be careful, k is power of 2, the scalar. So now let us start with this. You can see here I want A, right? Now to proceed with this, A power n is equal to 2 power k into A. If I say n is equal to 1, I am going to have here A power 1 is equal to 2 power k. Correct, na? See carefully, here also A, here also A, so this scalar should not be there. So it means that the value of k should be 0. So A power 1 is equal to 2 power 0 into A. This should be our first relation. Now let us go to the option. Put, see, A power n in place of n 1. Put in all the option n is equal to 1, and the power of, nothing but the value of k should come to 0. Let us see. So if I put 1 by 1, n value to be 1 because A power 1 here. So here what I am going to get, and don't forget all these are k values. So k is equal to, I am getting 2 power 1 minus 1 will be 0. 2 power 0 is 1, but I want k value to be 0. So option A out. After getting my point. This all about k values. And we have got 2 power k. A is equal to A. If at all A should be equal to A, the scalar power k should be 0. So I am searching for that value of k. This all are k values, possible k values. I want that option which can give us what? 0. So again, here also option B this is. So k n is equal to 1. So here k value, it is 1 plus 1 is what? 2. But I want k to be what? 0. Option B is out. Come here. Again when I say n is equal to what? 1. Put here k value is 1 minus 1, 0. Yeah, we got it, but hold on. Check the other option. Okay. So when I put again here n is equal to 1, we get 2 times of 1 minus 1, 2, and here it is 2 into 0. 2 into 0 is what? 0. We have got 2 possible. So we have eliminated this. Now let us try to find a square. Let us try to find a square. Ready? So for that, let us find a square. A square will be A into A, nothing but this matrix. I will just write 2 minus 2 minus 2 2. and again 2 minus 2 minus 2 2. As you can see very clearly here, if I take 2 common, I will get 1 minus 1 minus 1 1. Again here also 2 common, if I take, I'll get 2 square, because here also 2 common, here also 2 common, 2 square I'll get. So here it will be 1 minus 1 minus 1 1. Now a square will be 2 power 2. Now multiply row versus column. 1 into 1 1 minus minus plus 1 will be 2. 1 into minus 1 is minus 1, minus 1 into 1 will be minus 1 minus 2. Again I'll get here minus 2, and again I'll get plus 2. This is same as equation number 1. So we are getting a square is equal to 2 power 2, and this entire is matrix A only. Okay. Now again, don't forget we have k. So k value we have got to be 2. So it means in both this option, when I put n is equal to 2, am I getting k value to be 2 or not? I have to check. Don't go for A and B, they are already rejected. This is what when we go with the option, no? The option which is already rejected in the previous trail of values should not be considered again for the next. Okay, it's not only for true for matrices, for any, whenever we go with the options. Now only option C and D I have to check, and here I should get k value to be 2. So since it is a square, so n values, this is all n stands for power of a. So put n is equal to 2. Now option C, if you see 2 minus 1, k value 2 minus 1 is 1, but I want k value to be 2. So option C rejected. Now see option D, k value, yeah, 2 times of n is 2, 2 minus 1 is 1, so 2 times of 1 is 2, so k value is 2. Yes, option C is correct. Okay, so kindly make a note. Dear students, let us move on to question number 69. Question says if A is a skew symmetric matrix, then A power 2021 is row matrix, symmetric matrix, column matrix, or skew symmetric matrix. Which is the possible answer? I would like you to recall this note. What? First point. If A is symmetric matrix, if A is symmetric matrix, then A power n, where n is any natural number, is again a symmetric matrix. How, sir? Very simple. If I say A is symmetric matrix, A is what? Symmetric, nothing but A transpose is equal to A itself. Now I want to talk about A power n, whether it is symmetric or skew symmetric. For that, take transpose. If I take transpose, be careful. I can always interchange the power and transpose, so I'll get A transpose whole power n. But what is A transpose from equation number 1? A itself. So I will get A back, because A transpose A itself and A power n, and left hand side as it is, A power n whole transpose. Is it not? It's opening the definition. A transpose is equal to A. Whichever matrix is there inside the transpose, same matrix I should get back. Inside transpose we have got A power n, I'm getting back the same. Therefore, this implies A power n is again what? Symmetric matrix. Should also understand here, when I'm saying n is a natural number, it means if A is a symmetric matrix, you should understand, as soon A is a symmetric matrix, you should understand A square, A cube, A power 4, and so on, up to whatever power we take, all are what? Symmetric only. That's what we have got. Even actually inverse is also symmetric only. Let us make one note here. Also, inverse is also what? Symmetric matrix. Note number 2. What if A is skew symmetric matrix? Let's have it. If A is a skew symmetric matrix. Now, as soon as I give this general result, as soon we'll get any problem. For example, here it is A skew symmetric, but let us suppose A was symmetric matrix given, then A power, okay, power is what? Natural number. It's again what? Symmetric. Now, for skew symmetric, what's going to happen? See, for skew symmetric, we know the definition says A transpose should be equal to, A transpose is equal to minus A. Now, coming to the power, see carefully. Then what about A power n? Now see, when I talk about A power n and I'm applying the transpose, again by using this rule, what? That always, should I write that rule here? Always transpose and the power can be exchanged. Correct now? So here, A transpose the whole power n. What is A transpose minus A? Right? Now see carefully. Minus A whole power n. Now comes, if negative is out, I'll get skew symmetric because it will obey this definition of skew symmetric. If negative is not coming out, is positive, then it is what? Symmetric only. So it completely depends on the power n. So let us comment here. Therefore, A power n whole transpose this is equal to minus A power n. This will be, if n is even, if power is even, negative convert to positive, so I'll get plus here. Okay, comma this is. If n is what? Odd, then since n is odd, negative will come out. Okay, power n as it is. Okay, power n as it is. Minus A power n. Just give some space here. So A transpose whole power n is equal to A power n. Nothing but is symmetric if n is even. A power n whole transpose is, I repeat, A power n whole transpose is A power n if n is even, nothing but it will be symmetric. And A power n whole transpose is equal to minus A power n when n is odd, nothing but it will be skew symmetric. So I can conclude from here, one conclusion can make it here. Therefore, A power n, we can have two things. It can be symmetric if n is even, and it will be skew symmetric. It will be skew symmetric if n is odd. But here in this case we are talking about, in both these cases, what's common means what we are assuming, A is skew symmetric. If A is skew symmetric, two things can happen depending on the power. If power is even, it will be symmetric. The skew symmetric matrix will convert to symmetric if power is even. If power is odd, it will remain skew symmetric. Now come this question. If A is skew symmetric matrix, then see the power here. Power is odd or even? Odd. Power is odd. Therefore, it is again what? Skew symmetric matrix only. Option D is correct. I hope this point is clear. As in the year 2022. Now, I just want you to remember this result. No need to again prove it. Whenever the model result to be remembered. If A is a symmetric matrix, whatever power you take is again what? Symmetric. But if A is skew symmetric matrix, then you should be very careful with the power. If the power of the matrix A is even, it will be symmetric. If the power of A is odd, it will be skew symmetric. Okay? Kindly make a note. One question might come, sir, what if, and here, this question will come. Here you said inverse of a symmetric matrix is again a symmetric. What about skew symmetric? For skew symmetric, inverse will not exist. Determinant of that will be 0. That you will be seeing in the chapter determinants. Okay? Kindly make a note. Or we can make a note here itself. No. If one note, let us have it here. If A is skew symmetric of odd order. Okay? Skew symmetric matrix of odd order. Of odd order. When I say odd order, what's the meaning? 3 cross 3, 1 cross 1, 5 cross 5. Then inverse does not exist. Yeah, solely for even order, inverse exists. Okay. And how to find inverse, you know. That will teach anyway. We'll take our problem on that in the which one? Determinants chapter. Kindly make a note. Okay. Dear students, let us move on to one more question. This has been asked in previous year Kcet 2009. Question says if A and B are square matrices of the same order such that A plus B into A minus B is equal to A square minus B square, then, see, I just want to spend some time to discuss this part. Recall, let's take as a note. First, what is A square? Means multiplying A twice. Similarly, A square is multiplying A twice. A cube, multiplying the matrix A thrice, correct? So A power n multiplying the matrix how many times? N times. N times you have to multiply. Okay. Now what's the meaning of A plus B the whole square? Multiplying the matrix A plus B how many times? Twice. Now when I multiply, see carefully. I am multiplying twice. Now let us multiply. A into A square. A into B, AB. B into A, BA. Then B into B, B square. This is the result of A plus B whole square. Don't forget, under matrix multiplication, commutative did not hold good. Commutative need not hold good. We have already discussed that. So whenever I am talking about A plus B whole square, it's only this result. A square plus AB plus BA plus B square. If I ask about A minus B whole square, that will be A square minus AB minus BA plus B square. That's it. Similarly, if I ask you what is A plus B into A minus B, multiply these two matrices, A into A square. A into minus B will be, okay, plus into minus, I'll get A into B. Again, multiply this B into A. Again, plus into minus, B into B is B square. So minus B square. That's it. Okay. Now, you will be having a doubt. Sir, in school days, we have learned A plus B the whole square is A square plus 2AB plus B square. Now, sir, how can you change the result? Dear students, understand. When you have went for this A plus B whole square in the school days, you have multiplied A plus B how many times? Twice. When you are multiplying twice, A into A square. A into B, AB. Then B into A, BA. Then B into B, B square. This result got reduced to this because in real number, A into B same as B into A. Nothing but all coming to real number system, commutative is always true, due to which AB plus BA is 2 times of BA. So we are going to have 2 times of BA or 2 times of AB, both are same. This is how we got the result. But coming to, and I again make it very clear, under set of real numbers, commutative is always true. But coming to matrices, commutative did not be true. Now, if I impose a condition, what? If A and B are commutative, what's the meaning? That is, A into B same as B into A. Then this second one will change to A plus B the whole square is equal to, since AB and BA are same, so AB plus BA will be 2 times of AB, and A square plus B square as it is. So understand, as soon you see in the question they have written like these, what? same as your school test formula. They are saying that they have assumed the given matrix to be commutative under multiplication. This point I want you to understand. Similarly, for a minus b whole square, if I'm writing a square minus 2ab plus b square, they have written under the assumption that it is commutative. This should strike. Similarly, this part, a plus b into a minus b, let us write that a square minus ab. But since we have assumed it is commutative, what's going to happen? B is same as AB plus B square. Now here both minus AB plus AB will get cancelled. We are left with A square minus B square. So whenever you see any result of this form directly written like our school days, it's very clear that it is what? Under the assumption that it is commutative. Similarly, a plus b whole cube, which is a cube plus b cube plus 3 times of a square b plus 3ab square. That also, if I write like that matrix, if I write in this expansion form, it's under the assumption that it is commutative. Okay. Now come to the problem solution. So a and b are the square matrices of the same order such that a plus b into a minus b is equal to a square minus b square. This part is giving one comment that it is commutative. To highlight, to make you understand how can I assume that it's commutative, I have explained this. So in short, what you have to remember, whenever you see anything written in the form of a school test formula, this one, a plus b whole square, a minus b whole square, or this, if it is written in the form of this, it is what? Under the assumption is commutative. If it is not written, yeah, just they have multiplied and kept as it is. And it is not commutative. Now, this is commutative because this is exactly going with this. Now, let us try to find what is A into B, A inverse whole square. See, since we came to know that it is commutative, we can exchange AB to be BA and then A inverse as it is. So I have extended because this is commutative. Now recall what is A into A inverse. It is identity, invertible matrices we discussed. So B times of A into A inverse is identity, then the whole square. Again recall what is any matrix when I multiply to identity, we get back what? The same matrix A. So whatever matrix is there here, same matrix will be there when you multiply with the I. Nothing but multiplicative identity we discussed on property. So B into I is B and square as it is. So answer is B square. Option C. You can see there are so many problems where there is no usual way or what we have learned in PUC, but with PUC knowledge we are able to solve. Okay, surely nothing is something like not important. Everything is important. Okay, I hope this point is clear. And I want to highlight one more point that as a note you can have. Whenever you multiply any identity matrix n number of times, again you will get identity only. You can check. Similarly, whenever you multiply any zero matrix n number of times, you get what? Zero only. Okay. Not only that, inverse of identity matrix again inverse, and inverse of zero matrix does not exist. Why? Recall determinant, that determinant should not be equal to 0. Determinant of zero matrix is what? 0 only. Okay, fine. So I hope this point is clear. Kindly make a note. Okay, dear students, we are with the last problem from this chapter. Totally 71 questions I have covered only for matrices, and every year we can see that we are getting 2 to 3 questions from this. Okay, and each question is giving 1 mark. Very important. Now, coming to the question, if A is a square matrix, then A into A transpose is which type of matrix? Coming to solution of this, let us take the matrix as some matrix B. See, they have said If A is a square matrix, then what can be? And see, this I have taken to make you understand as soon a general means. See, previously A is symmetric matrix, then A plus A times. Okay, let us go ahead again. If A is a square matrix, we already know A plus A transpose symmetric, A minus A transpose skew symmetric. Scalar multiple of a scalar multiple of a symmetric matrix is again symmetric. Scalar multiple of a skew symmetric matrix is again a skew symmetric. All those we know. Now let's suppose suddenly we'll get some matrix like this. How are we going to go about? I thought I'll take one problem on that. And this is asked one of the previous year question. I just forgot to mention the year for a while, but I mentioned the year as well. Just give me a time. This is asked long back 1991. Sir, then why are you discussing now? It's all a problem of basic ones. It can be again asked. Okay. Now we just try to give this a year. No, then curiosity will be there. Oh, it was asked. Now, whether it's symmetric or skew symmetric, we have to take transpose. If I take transpose on both the side, don't forget the reversal law. A into B, the whole transpose is B transpose into A transpose. The order will change. First matrix, second matrix. Now the second matrix, then first matrix. Here the first matrix is here, second matrix is A transpose. So the order will change. So I'll get second matrix A transpose. See, second matrix, then take the transpose. So second matrix A transpose, then again we have a transpose, then A transpose. And we also know that if I have got transpose twice taken, I get back the original matrix here only. So A transpose, the whole transpose is what? A itself into A transpose. What is this from equation number 1? Same, B. So I got left hand side B transpose equal to B. Therefore, B is equal to A into A transpose is symmetric. It obeys the definition of symmetric matrix. So it is a symmetric matrix, which is then option A. Option A is correct. So kindly make a note of this. Yeah, dear students, with this we come to an end to the, I repeat, we come to an end with respect to the chapter matrices on Kcet. Totally 71 questions we have discussed. All the very best, do well, give your 100% dedication, try to understand each and every problem, don't try to mug the things. Yes, their results will be remembered, logics will be understood. Okay, all the very best, do well, give your 100%, be dedicated towards the studies, and God bless you all. And lastly, do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.